In this video, we're going to look at factoring trinomials of the form x squared plus bx plus c. This is also known as the leading coefficient is equal to 1, or a is equal to 1. Okay, so when we see these, generally, as I've mentioned before, when we're factoring, it looks like things that need to be multiplied. So we're going to do the reverse for just a second. We're going to look at what happens when we have something in factored form, like x plus 4 times x plus 2. So if we were to go from factored form into simplified form, you can use the distributive property, or sometimes we call it the FOIL method. That's multiplying the first terms, the outer terms, the inner terms, and the two last terms. And then we combine what we can combine. So that would be x squared plus 6x plus 8. But what we want to do is we want to go in the reverse direction. So we're going to be given something that looks like this, and we want it to look like something like this. When we're factoring trinomials of this form, there is a shortcut that we can use that we're going to talk about in this video. This is a shortcut that we use only when the leading coefficient is 1 and never any other time. If the leading coefficient is 2, this method does not work. If the leading coefficient is 17, this does not work. So this only works when the leading coefficient is 1. And so let's look at what we have. So here in the middle, we have 6x, and here at the end, we have 8. Well, how does 6 relate to 4 and 2? And how does 8 relate to 4 and 2? Well, 6 is 4 plus 2, which we see right here, or 2 plus 4 in this case. Same thing, 4 plus 2 and 2 plus 4. So this number here is the sum of the two pieces, second pieces of each binomial. And 8 is 4 times 2. 4 times 2. So when we're factoring trinomials with a leading coefficient of 1, the shortcut that we can use, so if we have x squared plus, let's say, d times e, d plus e times x plus c. Is this really what I want to do here? Oh yeah, sorry, we're going to change that to plus de. There we go. So if we have x squared plus two things that add up to this, and those two things also multiply to that last term, then it's going to factor into x plus d times x plus e. So as long as we can think of what I usually call this last term, I call that the target product. So we're trying to figure out two numbers that multiply to that. And also those two numbers need to add up to this, so I call that the target sum. So we say b is the target sum. And c is the target product. It's usually easier to start with the target product because generally there are fewer things that multiply to numbers than you can always find things that add up to numbers. So let's look at our first example, letter A. We have x squared minus 10x plus 21. So our target product, our c, is 21. We're looking for two numbers that multiply to 21. But also, the target sum is negative 10. We're looking for two numbers that will add up to negative 10. So 21 has factors of 1 and 21. That won't work because 1 plus 21 is equal to 22. And then if you made those both negative, that would be negative 22. So that's not going to do it. But also 21 is divisible by 3 and 7. And then 3 times 7 is equal to 21. But we need the sum to be negative. So rather than positive times positive, if they're both negative, it would multiply to something negative and add up to something, negative times negative would multiply to something positive and add up to something negative. So if the winning combination is negative 3 and negative 7, that would be positive 21 when you multiply, negative 10 when you add. So we can rewrite this in factored form as x minus 3 times x minus 7. The order of these pieces doesn't matter. If you put x minus 7 times x minus 3, that's the same thing because those two factors are commutative. So we could just go right from here to here. Negative 3 times negative 7 is positive 21. Negative 3 plus negative 7 is negative 10. Our next example, we'll try to do this in a shorter amount of time. Let's see. We have our target product is negative 12, and our target sum is negative 11. So we do have some hints about what these numbers are. We know that one has to be negative and one has to be positive because the product is negative, and that's the only way that we can get a negative product. The sum is negative, so that means of the two numbers, the bigger of the two must be the negative. So two numbers that will multiply to negative 12 and add up to negative 11, that would be negative 12 and positive 1. right? If you look at any other combination, 6 and 2, you're not going to get 11. 3 and 4, you're not going to get 11. So the winning combination is negative 12 and 1. We just fill those in. It would be y minus 12 times y plus 1. It would also be correct to say y plus 1 times y minus 12. But note that the sign does matter. It must be, the 12 must be negative. Otherwise, we won't get that middle term to be negative 11. In letter C, our last term, our target product is negative 20. Our target sum is, when there's no number, it's a 1 or a negative 1. Since there's a negative in front, it's going to be negative 1. So we're looking for two numbers that multiply to negative 20 and add up to negative 1. That would be negative 5 and positive 4, right? Because 10 and 2 won't work, and 20 and 1 won't work either. So we can just plug those right in. That would be c minus 5 times c plus 4, or c plus 4 times c minus 5. Last but not least, negative 2w cubed minus 34w squared minus 144w. We have a few issues here. First of all, the leading term is negative, so I want to factor out a negative, but also I see that the three terms have a GCF. I want to make sure I pull out that GCF, and I can show you why after I pull it out and get the correct answer. Then I can show you why we need to pull it out. So we're going to factor out negative, and then these are all even, so they're all divisible by 2. W cubed, w squared, and w will all have a w in common. And now we're going to divide negative 2w into all three terms. Negative 2w cubed divided by negative 2w will be w squared. Negative 34w squared divided by negative 2w will be positive 17w. Negative 144w divided by negative 2w will be positive 72. Okay, now we need to see if that trinomial inside the parentheses is factorable. With the GCF, we keep bringing it down, but we otherwise ignore it. So our C in this case will be 72, our target product, and our target sum is 17. So we're looking for two numbers that multiply to 72 and add up to 17. The winning combination would be 9 and 8. Okay, so those are going to plug into our binomials, and we'd be left with negative 2w times w plus 9 times w plus 8. Now, just to go back, if you, well, you can't do this because you don't know how to, in this video we're not talking about when the leading coefficient is something other than 1. And this is kind of a messy one, but what would end up happening, this is a little bit different just because I'm not going to factor this one in my head. If we have 2w minus 4 times w plus 6, let's say, we would not consider this to be fully factored because one of the two factors still has a GCF. So if you don't pull out the GCF in the beginning, you're going to be left with a factor that can still have a factor get pulled out, which is fine, but frequently if you don't pull it out at the beginning, you're going to forget about it later, or you're just not even going to think to check to see if they have a GCF. But it is possible to still get the fully factored form. You would divide this by 2 and pull the 2 out in front, so it would be 2 times w minus 2 times w plus 6. So you can still pull it out at the end, but very frequently everyone forgets to do that, myself included.